In this screencast, an autopsy of Berlin's public transportation system is conducted, exposing the blood vessels of the city. This is achieved by exploring the GTFS data provided by the VBB and visualizing the most important inner-city routes for buses, trains and underground on a map. The result will look like this. This is a map of Berlin. The different bus routes are outlined and colored. You can select and highlight single routes and you get additional information regarding the individual bus stops via tooltips. The outlined concepts in this screencast can be applied to visualize public transportation routes of any other city that provides data in GTFS format, such as New York or San Francisco. We will use the following technologies and tools: a virtual machine on Microsoft Azure with a standard A5 processor, 2 cores and 14 GB of main memory, Hortonworks Sandbox, which runs on the virtual machine, Ambari, the software for Hadoop management, Hive, the data warehouse for HDFS, Zeppelin, a web-based notebook and multi-language backend for Hadoop, and Tableau for visualization. This screencast will cover 4 parts: preparing the data, loading GTFS data into Hive, exploring GTFS data with Zeppelin, and visualizing GTFS data with Tableau. Let's start with the first part, preparing the data. In order to get the data, we just Google for VBB GTFS data and we search for Verkehr offene Daten Berlin, a webpage that is unfortunately only available in German. Here we have several entries for scheduling data. We just pick one of them randomly. We get additional information about that dataset and we can scroll down to the download button, which is called Zur Ressource. Just click it and the data will download. After extracting the downloaded zip archive, you will find a bunch of files that altogether form the GTFS format. A few of them need additional cleaning, for example the trips.txt file. Here we have to remove all the quotation marks, otherwise we would run into trouble when we upload the files into Hive. You can remove the quotation marks just by executing a simple find and replace operation. Hive is a little bit picky when it comes to dates. So we have to replace all the date values we can find in the GTFS dataset, for example in the file calendar.txt. We can replace the date values, or we can put them in the right format, by executing a find and replace operation as before, but now we do it with a regular expression. Just replace all the values and Hive will be happy later on. Talking about Hive, let's start to load some data into it. This is the HDFS files view of Ambari, and here we need to go to the temp folder where we will create a new directory for the GTFS data. Let's call it GTFS data, and within this directory we will upload all the GTFS data from our local hard drive. After uploading all the files, we need to go to the Hive view in Ambari in order to define the tables that will hold the data later on. First of all, we will create a database which is called Transit. We did it already, so you can see it here on the left side in the Database Explorer. Also, we need a SQL script in order to define all the tables we need later on. We define the tables according to the GTFS standard. So you can see here we have an extensive SQL script where all the tables are defined. After executing this SQL script, the newly created tables should be visible below the Transit database symbol on the left side. Now, all the data from the uploaded files need to be put into the tables, and therefore we need a new command. Load data in path, here we have the path on Azure, and overwrite into table transit.agency. We have to do this for all the different files, and after that all the data is nicely stored into our tables. Now it's time to have a deeper look at the GTFS data, and we will do this with Zeppelin. This is the starting page of Zeppelin, and you may have to create a new node. We already did, and we called it Berlin Transit, and we will have a look at it. The first thing we want to do is to inspect the agency data. In order to draw a map with all the U-Bahn connections in Berlin, the agency ID of the BVG Berliner Verkehrsbetriebe needs to be found. Therefore, the table agency is checked. And in the end, you can see we find our number 716, it's the BVG Berliner Verkehrsbetriebe. Next, we need to find matching routes. According to the agency ID, matching routes need to be identified. The BVG in Berlin provides a lot of different routes for all the buses and trains. The overview on this table helps to select routes of interest. And as you can see, we have a lot of different route IDs. We just check which route name is interesting for us. The next step is to identify matching trips. So for each route, there are tons of different trips which will later refer to the actual geolocation data for one route. The idea of all the trip data is to provide alternative routes in cases of an exception, so we must decide for one. The selected trip needs to be assessed, because some trips are very short, and as we want to find longer routes, the previously selected trip is inspected in greater detail. And as we can see here, for this trip, here are a lot of stops. That looks very good. After identifying an interesting trip ID, we want to create a dataset for visualization. And the dataset will look like this. So we have a route, the stop name, the stop latitude, the stop longitude, the stop sequence, and a stop ID. We can put the trip ID into the insert statement and extend the dataset. The resulting dataset is the basis for visualization. Let's move on to Tableau in order to visualize Berlin's bus, S-Bahn and underground. After starting Tableau, we need to connect to Hortonworks Hadoop Hive, either here on the left side or by clicking More Servers and find the correlating item here. We have to enter the IP address from our virtual machine on Azure, change the type of the server to Hive Server 2, choose username and password, and enter the correct information here. Then click OK. In the data source view of Tableau, we will select our schema, which was called Transit. Also, we have the opportunity to check all our tables, and we find our predefined table transit.bus right here. We drag and drop it to the upper field, and we get a preview of all the columns. Also, we need to set the connection from live to extract, because we want to have all our data on hard drive, otherwise it would take forever to load the data from Hadoop. Now that we extracted the data, we want to do something with it. So let's go to sheet 1. And the first thing we have to do here is to convert all the measures into dimensions. This is very easy, just right click on the measures and then click on Convert to Dimension. Next, we want to double click on Stop Lat and Stop Lon, and as you can see, Tableau already puts a lot of points on a map. Nice. Now it's about connecting all the dots with each other. So we go to the Marks panel and set this one here to line. Also, we will take the stop sequence and drag and drop it to the path. And we will take the route and drag and drop it below the stop sequence. And right now everything looks really fine. All the dots are connected and we have a first idea of all the routes for the buses in Berlin. Additionally, we can add and edit the tooltips for all the routes. So let's grab stop name, put it into tooltip, and as you can see here, we already have some additional information about that route. So we can see it's M49 and the stop name is Heerstraße. That is really nice. By double clicking on the tooltip symbol, you have more options for formatting the tooltips. Almost there. Now we have to group the routes. Just right click on one route, select group and group by route. You can select any other route and also group it. Actually, you have to do it for all the other routes. Group, 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 all the way. Then you can see the groups here on the left panel. By clicking here on that arrow, you can say highlight selected items. And now you are able to highlight single routes individually. Very nice. Also, you can change the color, more specifically the type of marker, into the middle one. And for each stop, you get a little dot. In the end, your result may look like this. A picture of all the different bus routes in Berlin with nicely formatted tooltips. Also, we have the Berlin S-Bahn on a map with a black background, and also the Berlin U-Bahn, also on a map with a black background, which looks very nice, I think. You can zoom in, you can change the route, you can highlight individual routes, just as shown before. and you could print it out and make a poster out of it. And this is the end of the tutorial. Thanks for watching and have a great day.